This should do it. Okay, so welcome back, everyone. Okay, and the tiles. Where are the tiles? Let me see. Participants are there. The tiles the last time. All right, well, you can keep your microphones muted or unmuted. If you have a question or a comment, just open your mic and let me know. The convention is that you say your first name and then pause for a moment, see if anyone else is talking or not. No one else is talking, then you can just jump right in, okay? So let's go right to it. This is the third session, the third workshop out of 4 on the ethics of scientific research. And my credentials academically, I'm a professor at St. Thomas University for about a dozen years now in biology and bioethics. And academically, I have a doctorate in moral theology from the Pontifical Gregorian University in Rome, Italy, and also doctorate in genetics from Purdue University. And those are essentially the 2 main fields for teaching bioethics. On the one side, the scientific part, and the other one, it could either be in theology or in philosophy, the other degree, because ethics can be approached either from a philosophical perspective or a theological perspective, okay? All right, and I also give credit to all of the work that I'm using. Basically comes from this little booklet on being a scientist, the 3rd edition, which is published by the Committee on Science, Engineering, and Public Policy from the National Academy of Sciences, the National Academy of Engineering, and the Institutes of Medicine. You can download this booklet for free at this website. And I send you also the PowerPoint, or we post a PowerPoint in our Google Share, so you have access to all of this, all right? Okay. All right, so today we're going to cover 3 topics. Again, we're going to look at briefly at lab safety, and I'm not going to spend too much time there. And then we're going to look at publications, the development of a manuscript, and then the publication and the authors that should go on that scientific publication and so forth. So moving forward then, on laboratory safety, I mentioned I'm not going to spend too much time because I believe you have had a course in this already, or a video, I think with Dr. Tapanes at St. Thomas University and also at MDC with your own professors there. You've done already some aspect of laboratory safety, lab safety, okay? Briefly, there's a list here of things to keep in mind in a lab, because in a lab, we'll be using equipment that sometimes is expensive equipment, sometimes it is delicate equipment, or it could be dangerous, chemicals or other machinery, voltage, and so forth. So we just have to have safety in mind, safety of the people first, and also safety of the equipment in general. So appropriate usage of protective equipment and clothing. One big thing here with the clothing is particularly with the shoes in the summertime, that people like to wear sandals or flip-flops and so forth. None of that really is appropriate in a lab. I think it's been emphasized before that there should be closed-toe shoes, right? Closed-toe shoes. They may not be pretty, but that's the type of shoes that we need to use in a lab, just in case something drops to the floor or near our feet, that we don't sustain any injuries, okay? Also, high heels are not the ideal in a lab either, simply because of the practicality of moving around, and just in case in the outside possibility that one has to leave the lab quickly, no running, but moving fast, the high heels may also be a problem, okay? Anyway, safe handling of materials in the lab, including using gloves and so forth. Maybe goggles are also needed, depending on the protocol of the experiment. Safe operation of equipment, proper disposal of materials. Typically, there will be a lab assistant or lab professor who is guiding the students, and that lab professor will point out where the different materials are poured out, whether they're liquids or solids, whether they're toxic or not, and so forth. That is what we call the waste streaming that needs to be documented. That falls on the side of the lab professor or the technician who is managing the lab. Okay, safety management and accountability. Hazard assessment processes, yes, it depends if we're using hazardous materials or not. Hazardous material could be chemical, could be heat, could be also radioactive, for example, etc., for labeling. So hazard materials, there's all kinds of protocols to deal with that. Transportation of materials between labs in the same building, even on the same floor, moving across the hallway may require some particular equipment, some special equipment, okay? Design of facilities also has to be considered. Emergency responses like the shower, like the eye wash. The eye wash, for example, needs to be turned on periodically to make sure that the water is flowing normally and has not accumulated there over weeks, or accumulating dust or other particles, because then it will splash the eyes. It's meant to rinse the eyes and not to damage them, injure them further. The same goes with a shower that is just outside labs, again for safety, that in case there is a spill on the body, on the clothing, that shower will be very useful. Safety education for all personnel before entering the lab, yes, and typically this is on the first day of the lab, the safety videos and the talk on all this, all right? And lastly, to consider some government regulations that may apply with or without grants, because if we have federal grants or state grants, whatever, typically there are some regulations that apply with that grant, but even if there's no grants, there are regulations that apply. For example, the hoods that are used in chemistry labs to extract toxic fumes and so forth. One thing that I did want to mention here, kind of associated with the lab safety on the ethical side of things, is the notebook. So I wanted to take a little bit of time here, and there are no particular questions for this section. I'm just making a comment. But raising it to the level of the ethics, because you notice that you have your timesheets coming up pretty soon, right? Can anyone remind me when your timesheets are due?
June 30th.
June 30th, okay, so that's coming up. Then you're keeping a log of your time at home, okay, and these are special circumstances with regards to, because of the virus, we cannot be actually physically in the lab when we see each other on a daily basis, and we more or less have an idea. We professors, researchers, the PIs, the principal investigators, we have an idea of who has been in the lab at what time and so forth. But now, for the time being, everything is virtual. So essentially, we have to trust you, all right, that you're doing the right thing and that you're logging in your timesheets the correct amount of time, Okay, very important. This is part of the rigor, if you will, and the discipline. We talk a lot about the honor system. I'm sure you've heard about this before, even in high school and whatnot. But the honor system basically means that we are supposed to behave correctly with a conscience that is mature and responsible, and to make that effort to log in your time on a daily basis, whatever time you spend. I don't know if did MDC or Dr. Tapanes give you some guidelines with regards to what to do, for example, with half hours or quarter of an hour, rounding up or down, or what? Did you get some guideline there? Anyone?
Mostly we are putting the entire hour. It depends on if if it goes like until now there was no meeting that we did like 20 or 15 minutes and no other like webinar that we went to. So mostly we go for like 50, 40 or 1 hour meeting up to 2 hours meeting.
I see. Okay, so if you start working on a project, for example, if you get on Labster and doing some exercises there, or doing some research or some kind of project in Labster or in R, I saw that Dr. Mondesir is also publishing some stuff for statistics in R. You'd be doing that on your own individual time. Do you just record when you start, for example, at 9:35 p.m. and when you start the project, and then when you finally finish that session at 10:42 p.m., do you record just those numbers down to the minute, or what?
Yes, exactly. Like we
Yeah.
are doing the I'm in Dr. Tapani's laboratory, and
Okay.
then we are doing this things in our studio with Dr. Mondesire. And yes, exactly. We just record the time that we're doing. She said also we were like doing some research now on the COVID workshop,
Yes.
and what we were doing actually, she told us like some that there was like a research made from scripted that she told us to watch in order
Yes.
to just fulfill more information, and she just put like just put like how many minutes that the video has, and you put like the hour that is your research, that is your laboratory that we are doing for now.
I
And
see.
the
Okay.
thing on our studio, we're gonna go back on the next week because we stopped to do this workshop. We are doing this. We go work a little bit, at minimum 1 hour, and then that's it for the day.
I see. Okay, so you're recording then. All right. It gets a little tedious when you have to record down to the minute, but I guess for now, uh, that's what you need to do. You could start a spreadsheet, for example, on Excel. Do you all know how to work Excel, at least a little bit, with the different cells that it has? Because Excel can help you do the calculations and do your additions of the time. Um, but okay, so my point here is basically that you need to keep track of your own time, and whatever you're researching during the summer, that counts. If you're doing any kind of research, if you're looking up stuff, you're reading articles, you're looking at news clips, whatever it is that is involved in the summer research, all right, you keep a track of that time, and that goes into your timesheet. And basically that's where honesty comes in, to not put more or less of the actual time that you spend on that research, on that project, or whatever study you were doing, and just keep it honest. So it's going to be on each one of you really to maintain that spreadsheet. I think then moving forward, every 2 weeks, you're supposed to send your PI, email your PI a timesheet for those 2 weeks. And I think it's an average of about 15 hours a week, more or less. Is that what it is?
Yes.
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 Okay, yes, I remember Dr. Tappan is mentioning that to us, about 15 hours more or less. So if you divide it into 5, that's 3 hours per day, Monday through Friday. But if you extend into the weekends, then it's a little less every day on average, right? So maybe 2.5 hours daily. That's quite a bit of work when you do it on a regular basis. Okay. But also to know, once again, that if you're doing readings, associated readings on your own, that also counts as part of the research. And there's an element of curiosity here, all right? For example, you may be reading up, one thing that I would suggest, read up on COVID, which is, by the way, COVID is the name of the illness, all right, of the infection of the disease. But the name of the virus actually is SARS-CoV-19, and SARS, SARS, it's an acronym, all right, for severe acute respiratory syndrome, has to do with breathing. So don't get the name of the virus confused with the name of the illness. Most people refer to it as the COVID virus, but that's not the actual name of the virus itself. That's the name of the illness. It's like pneumonia. Pneumonia is the illness. Pneumococcus is the bacteria that will cause, is one of the bacteria that can cause pneumonia. But read those articles, read those 2 articles. So you can start with Wikipedia, for example, which is broad-based, and there's a lot of information there. And then you may be reading one sentence or one paragraph that there's some stuff there that you want to investigate further. So you get out of Wikipedia and you go into another source and you keep reading, and your curiosity is taking you in a particular route. That's okay, all right? Don't stray out too much from the original idea, whatever you were reading, but it's all right to allow curiosity to kick in, and especially if there are some terms or concepts that one doesn't understand. For example, Wikipedia may make a mention to what is herd immunity or community immunity, which is typical of mammals in nature, in the wild. Herd immunity, they become immune, the herd as a whole becomes immune to an infection when it's a novel virus, pretty much what we're experiencing now. So that concept, herd immunity, needs to be understood and see if it applies to us or not, and when would it apply. So that may take some extra reading in that area there, okay? So that's fine, you can include that in your hours, just make sure you keep a log of it. And but certainly watching cartoons or watching TV that has nothing to do with the research, that doesn't count at all. That's where the conscience comes in and the responsibility to be honest. Remember the value system that we talked at the beginning, to be honest with oneself and to be honest also with the peers and with the public at large. Okay, I think I've said enough there. Let's move forward now, unless there are any questions or comments, anything about the lab safety, and more specifically the lab notebook, which is what I was focusing on, or the timesheet, keeping the timesheet for your lab notebook. Everybody okay? Okay, I don't see any mics unmuted, so let's move forward then to the next little chapter here, which is actually
Dr. Cioffi?
Yes, go ahead.
Oh, yes, I had a concern.
Yes.
So like I received an email from the Miami-Dade, and they were saying that we had to have up to 30 hours, I think, for this week, for the 2 weeks that we've been working on all this stuff.
Right. Yes?
So like, do we like if we have like more than the 15 hours, do we record that or we don't go over the 30?
Yes. Okay, so these are averages, okay? These are averages.
Mhm.
So we always say the statement, on average, 15 hours a week, which is the same as 30 hours every 2 weeks, okay? On average. Does that mean that on 1 week, maybe you do 12 hours and then the following week you do 18 hours or vice versa? All right,
Oh.
so these are just guideposts, if you will, on average, about 15 hours a week, just to keep you and us on track too. But now after the first 2 weeks, you may have a little more or a little less than 30. You should be around 30 for the first 2 weeks.
Yes,
But
yes,
also
yes.
considering that they are indeed the first 2 weeks, you may be a little off. You may only have 25 or maybe even 20 hours. Well, that means you need to do a little more reading and a little more research in the next few weeks coming up. All right.
Okay.
But so don't fake the hours. In other words, if they say 30 every 2 weeks, don't report exactly 30. Report what you're actually doing.
Yes.
So
Yes.
don't fake the hours, and don't keep a second book where you have the real hours that you're going to make up and so forth. No, just state the honest hours that you're doing. Just try to stay on track to about 15 hours a week. All right?
I haven't calculated like my total amount of hours, but everything that I have assisted, I just had like recorded like the amount of time that I spent in whatever like webinars or
Yep.
anything that we work on, like in working any research or anything that
Sure.
we do. That's what I record, but I haven't like calculated the total amount. I was just asking so I don't go like over or less or anything like that.
Right. Okay. So I would say that when we finish here, which would be sometime probably around 4:30, maybe a little sooner, I don't know, around there. If you still have some time immediately after we finish, sit down and do that calculation. All right. You should
Okay.
try to keep a running log every day or every couple of days, add it up to see where you're at, just to have an idea where you're at. All right. It's a little bit like an electric car. You always want to know if you're in a, I have a fully electric car, all right, no gas at all, no gasoline. So I always need to know what percentage of battery I have left. Because I don't
Yeah.
want to find it out in the middle of the road. And I also, I always need to calculate the round trip, because if I go out with 50% of the battery, you know, I need the other 50% to go back home or wherever it is I'm going to recharge. So in other words, you should always know more or less within a day of where you are with your hours. So otherwise you may be surprised when you start adding all these up, you may be very short or maybe far over the 15 per week. All right. And that's why you're trying to minimize the surprises. There may be surprises along the way. Research always has some surprise, but you want to minimize those.
Yes.
Okay, Galilea, so maybe if you have some time when we finish, it may not take you too long, maybe 10, 15 minutes to do it. You can use Excel to do that again, but keep in mind that if you have hours and minutes, then it's not a decimal point, right? If you have, for example, 1 hour and 30 minutes, that's not 1 hour, 0.3, you know, that's 1 hour, what, point what?
1 hour
If you
and
have
30.
an hour and 30 minutes, hypothetically,
Yeah.
and you're going to turn that into a decimal,
It's 1.5.
is 1.5 hours, all right? So, but they'll be translating every minute into a decimal. That's too tedious. What you can do is just work 2 columns on Excel. Again, if you know how to use Excel a little bit, do 2 columns. We'll do 1 column for the hours and the next column for the minutes for the same time. So for example, an hour and 30 minutes, you would put 1 hour in one column, let's say column A, and you would put 30 minutes in column B. And you know that column B is for minutes. Then you add them all up, and the hours, you leave that number alone, that total number. But then on the minutes, let's say you get 600 minutes added up. You need to translate that into hours and decimals of hours. And then you sum that, you add that to the other whole number of hours. You follow me?
Yes.
Okay, so don't be confused there that minutes are not decimals of hours because it's a different scale. It's up to 60, it's not up to 100. Okay, if you have any particular questions about this, you can always send an email to your PI or to Dr. Tapanes, and we'll be glad to help you out, especially if you start in Excel. I'll be happy to help you set it up or help you how to calculate it, hours and minutes, all right?
Thank you.
Okay, sure. All right, so let's look at this research results, and then we have a little case right away with regards to research. You see there's a little bit of progression here. We're talking about handling the data and management of the data, and then when there is misconduct, when someone is manipulating the data in the wrong way, trying to fabricate or plagiarize information. Now we're going to look at the results of the research itself and how to share that, because at the end of the day, at some point we need to publish the results. We need to make the results of our research public, right? So that other researchers can use it and the science may continue to advance. The knowledge of humanity will advance by all of the research that has been done throughout the world, many, many labs. So here's a case, publication practices. We have this young professor, Andre, a young assistant professor, and two graduate students who are working with him. He's the PI, all right? He's got two graduate students, have been working on a series of related experiments for the past several years. So they've been at it for several years. Now it is time to write up the experiments for publication. But the students and Andre must first make an important decision. They could write a single paper with one first author that would describe the experiments in a comprehensive manner. Or they could write two shorter, less complete papers so that each student could be a first author. See, he's got two students under him. Sorry, I should have asked earlier. Can you see the my desktop, and can you read what I'm reading? Can you see it? Okay.
Yeah, we can see it.
Good. All right. Okay. So here we have a difference in opinions. Okay. The Professor Andre favors the first option. In other words, a single paper, more comprehensive, arguing that a single publication in a more visible journal would better suit all of their purposes. This alternative would also help Andre, who faces a tenure decision in 2 years. I wanted to point out here, I think I mentioned it earlier, he is an assistant professor, and typically there are 3 levels of professors administratively: assistant, associate, and full professor, okay? And typically the big jump is from assistant to associate, especially when the university has what is known as a tenure track. Tenure track, when a professor gets tenure, it's much harder to fire that professor, basically. It's a much more secure position. And once a professor achieves tenure in a university, then he or she can be there for years and decades, developing the field where he or she is researching, all right? That tenure decision here. And that's going from assistant to associate. And typically, professors come into a university as assistants or visiting professors and assistants. And they have typically about 5 or 6 years, more or less, to do some research, to get some publications. And the more substantial those publications are, the more likely that that professor will achieve tenure and then go from assistant to associate. And there's also a salary increase of a certain percentage salary. It could be 5, 10, 15% higher salary going into associate. And then a few more years and more publications, eventually the professor may become what is known as a full professor. But the tenure, he or she has tenure already, okay? So that single more substantial publication would help Andre, who faces a tenure decision in 2 years, see? So he's had about 3 years already, more or less, for research. Andre's students, on the other hand, strongly suggest that 2 papers be prepared, of course, because they each want to be first author. They argue that 1 paper encompassing all the results would be too long and complex. They also say that a single paper may damage their career opportunities because they would not be able to point to a paper on which they were first authors. So Andre needs to decide basically who is going to be the first author if it's a single paper. He's got 2 students and himself. I mentioned that in scientific writings, well, it depends on the field, but at least in natural sciences, typically the last author on the publication, on the list of authors, the last author typically is the PI, is the professor for which, who runs the lab, okay? Whereas the first author on the string, on the list of authors, is the student or the graduate student or the postdoc who did the most work, or made the most significant contribution to the research. And sometimes you have the case that the 2 students contribute equally, and the PI was very savvy the way he or she distributed the work to be done. And so both students really contributed equally to the research. But then there's a little note that is made, there's an asterisk or something that is put next to both names. And in the asterisk, it will say both authors contributed equally to the research. That's also acceptable, right? Of course, that option would mute this point because then they would essentially, both students would be essentially listed as first authors. But they're not considering that option here for whatever reason. They're just saying that there's a discrepancy. This little case wants to highlight a discrepancy between the PI and the graduate students who are working in this case, his lab, Andre's lab. So let's look at some questions here. How could Andre have anticipated this problem? And what sort of general guidelines could he have established for lab members? Anyone? Open questions here.
Karina.
Yes, Karina.
Yeah, maybe since he could have clarified that it was going to be 1 single whole publication, and that both lab students would be, like, all the results and all their work would come into 1 publication, and that at the end they wouldn't have the option to do 2 publications. Maybe that would have clarified and maybe anticipated the problem.
Exactly, kind of from the start, right? He could have even mentioned the issue of tenure. You know, there's no reason why he wouldn't mention that he's an assistant professor, and in a few years, he would a committee would be looking at his tenureship to see if he qualifies or not. So he's more interested in a more comprehensive paper. Again, the transparency is very important from the start so that everyone is on board. Mm-hmm. And there could even be guidelines set up, written guidelines, right, that he would give the students at the beginning, even when the students are considering to come into the lab or not. He could have some guidelines written up to hand out to the students to see if the students accept coming into the lab. So there has to be acceptance on both sides, on the part of the professor and the part of the students too. Okay, anyone else on number 1 question here? Okay, so this one then, basically number 1 kind of begs the question of having some kind of policies, all right? So if there are none of these policies, how can the issue be resolved? The discrepancy between the professor and the graduate students. If none of them wants to budge here, do they have recourse? What? How can this be resolved? Well, remember we talked about the IRB, for example, the review board, that could be one resource, or maybe the chair of the department, or maybe the dean of the School of Science. They could approach, the graduate students could approach those people, all right? Someone that may be a supervisor of the professor. Of course, this needs to be done in confidentiality, okay? But it can be done. Just approach someone else in the hierarchy of the university or the institution, mention what's going on and see what kind of recourse they have. Pretty much the PI has a lot of latitude, right? And I can tell you that typically the administration, unless the PI is really messing it up and doing some things that are unethical or very questionable, the university or the institution doesn't want to interfere too much. Part of it is because of the freedom of speech and freedom of academic freedom and research freedom, as long as it's within safety guidelines and things like that. Just internal policies of the lab, each PI is responsible for those policies, especially if the institution doesn't have much in by way of writing. But the students could approach someone else, of course, asking to keep confidentiality, but to see if they can get maybe this other person, maybe it could be a peer of the professor or someone else who knows a little bit about the topic that they're researching, and give an opinion as to whether it should be a single publication or both. There's no clear cut here, black and white, all right? How could Andre and the students draw on practices within their discipline to resolve this dispute? Okay, so that's looking at what is the convention, all right? What are the standard practices in that particular discipline? You can look at other publications and see how substantial they are, how heavy, how fat, you know. A lot depends on the journal where they're going to publish. Some journals are very, very focused. Many scientific articles are just 1, 2, or 3 pages long. They're not very, very long actually. But they're crunched, you know, they're substantial. Practically every word counts, and the figures and so forth. It's all very substantial. They're not very long articles. But they can get a sense on how much data actually, how much research is sufficient for a substantial publication. And if they've been at it for several years, again, I mentioned, at least in my experience, it was pretty much one publication a year. So if they have several years, they may have enough for more than one publication as such. One particular question I did have is how come they went for several years without publishing? Maybe that's something that slipped this young professor. Maybe he should have been publishing a little earlier and not allowed that much data to accumulate. Any opinion on that? When is the proper time for publishing? How much data does one need for publishing? So it's again, it's pretty broad. We talk about it to be a substantial contribution to the field. Also because if it's not substantial, it's not going to get accepted by the journal. Okay, and the paper will not have enough meat or bite to it to get published. So substantial, and everybody's looking to get more for less, right? And therefore the journals want to have as much data and significance and results as possible, because that advances that particular journal. Also, it maintains the prestige of the journal. They're not going to publish things that are half-baked or not that significant, okay? So that's always a back and forth. In fact, rarely do articles get accepted the first time that they're submitted. Typically they come back with some either rejected altogether or possibility of publishing, but with a number of suggestions and comments for strengthening the paper, where you may be required to do a few more experiments or to check some data, verify some data before resubmitting. But this one, a lot depends on how familiar the professor is with the field, all right? So they're looking for something substantial. That means that the professor should be familiar enough with the field to know when is sufficient data to get it published. Okay, let's go forward here. Let's see if the student feels that their concerns are not being addressed. All right, so this one kind of repeats on number 2. Who can they turn to? What is your feeling here? I mentioned some resources. Who can the students turn to if their PI is not listening to them? Doesn't want to consider their point of view.
Aren't there a board of other investigators or professors that they can talk to?
Yes, there can be formal boards or committees like the IRB, the Institutional Review Board, that's one. And informally, some of the colleagues, in other words, some of the peers of the assistant professor in the same discipline, in biology or chemistry or physics, whatever the discipline is, right? Maybe to check with one of the other professors. Maybe another professor who also has a lab and is known for publications and for that other professor's reputation and integrity, right? You find them. You students have been in studying long enough to know that some professors are more approachable than others. And that's just human nature, right? Some people are more shy or less communicative, etc. So there's always some professors that are more approachable than others, and typically students feel more comfortable there. So, but there are recourses. It's important to identify those professors from the start, so that they can be, again, we talked about mentors and advisors. Mentors go beyond advising courses for the next semester, is to listen to the students, take a more personal interest in their studies, in their life, in their progress as future professionals. Okay, so be looking out for those professors who could lend you a willing ear when you need to vent something. You don't know exactly how to do it. Okay, so what kind of lab or institutional policy could help disputes like this from occurring? So policies can certainly be established, right? Policies or practices written up, and it may be something as very blunt as the PI is the one who decides how many publications are going to be published with the data, or it could be when we reach certain thresholds, there can be some, the lab or the PI can establish certain goals within the lab and say, okay, for this year, for this year's research, we're going to focus on getting this particular measurement all right? And typically, since experiments have to be repeated several times in the lab and tweaked to really make it work well and get a clear result, then that goal may take several months or maybe up to a year to achieve that particular result that the professor is looking for. And there may be stepping stones, if you will, for going to the next phase of the research. So to establish goals for, like during the academic year, goals for this academic year, for example, or what he wants to establish or what she wants done in the lab, and have that written out. And these policies, they're working documents. It doesn't mean that that policy is set into stone and cannot be changed. Maybe if the research is showing the results that were unexpected or different results, that policy may change a little, okay? It could be they got the results in 6 months instead of a year. Well, that's great, then that's no problem. But it could be the other way around, that it takes longer, and then the policy can be adjusted. These are working documents. And there's no reason why they couldn't be changed as long as they're changed properly with consultation and reflection, what's best for the lab, really, for advancing that research. At the end of the day, it's trying to advance the knowledge in a particular field. Okay, let's go to the last one here. If a single paper is published, how can the authors make clear to review committees and funding agencies their various roles and the importance of the paper? Okay, again, another open question, but I kind of answered some of this anyway at the beginning. What's one relatively easy way to, these review committees are in the journals, okay? They're the ones who review the paper, and it could be just a small group of, in the review committee, 2, 3, 4, or it could be a larger group. But how can they, how can Andre and his graduate students let the committee know about who worked on the paper and what part of the research and so forth? Let's say that they both graduate students did put about equal amount of time and effort into the project. Anyone? I mentioned it briefly at the beginning. A little note, an asterisk next to both names, right? Put both of those names first, and put an asterisk next to each name, and then at the bottom of the first page, that asterisk with an explanatory note, very simply said, both authors contributed equally to this research, meaning that they're both really first authors. So that's one easy way of doing that. Sometimes also things can be posted online. This is an increasing practice now because sometimes data is very large and cannot fit, especially if people want to look at the raw data. It doesn't fit in the article because, again, I mentioned the article is very succinct. And so what a number of labs are doing is they have web pages where they publish the raw data with a code or something like that, with a lock, all right? And once the article is published, then they will say in the article, for those researchers or anyone interested in looking at the raw data, please send us an email and we'll gladly send you the code to get into the web page and look at the raw data or something like that, all right? So there's a way of keeping the data secure and at the same time sharing it with others. So that would be more for the funding agencies if they're trying to see how much work was done for the funds that were granted to the lab. And so the internet is always a great help, can be used in this way as a repository, like an archive where one can keep raw data virtually, and then it becomes accessible to anyone that we can make it accessible to without having to publish it on an actual paper, physical paper. Okay, so anything else about this general topic of sharing the results? Certainly when we're doing research, at some point we want to share those results. That's the way that science advances and knowledge advances. And there's a whole machinery of it that has been established for decades now, for a couple of centuries really, which is called publication of scientific papers in journals, scientific articles, in peer-reviewed journals, peer review. Peer review meaning that that review committee that is mentioned here, when the journal gets the draft, the manuscript, that journal has a list of researchers in different fields and will send that manuscript to this review committee for that particular field if they're working on DNA or proteins, whatever. Okay, or let's say that they're working on the virus, on the COVID-19. They're going to send it to some researchers who are familiar with that specific field. And these researchers, they will review the manuscript and give feedback back to the journal, and the journal will then pass it on to Andre. All right. Typically, it's the PI that has the communication with the journal. Okay, let's move forward then. Now, authorship and allocation of credit. This is going further into the publication itself. All right, the first one was more sharing the information. Now we're going to look at the authorship in a little more detail. So here's another little case. It's a short one. Robert has been working in a large engineering company for 3 years following his postdoctoral fellowship. Okay, postdoctoral, meaning that he has graduated recently with a doctorate in some field of engineering, and now he's working for a firm, for a company. It's outside of academia. He's in industry. He's in the business world, somehow in a company. Using computer simulations, he has developed a method to constrain the turbulent mixing that occurs near the walls of a tokamak fusion reactor. All right, so this is some kind of a nuclear reactor, a fusion reactor. And so he's maybe a computer engineer or something like that. And he has written a paper for physical review and has submitted it to the head of his research group for review. Okay, so the paper has not been sent yet. This is the journal, physical review, has not been sent out. He's following protocol. Obviously, this company, this engineering company, has a protocol established, which is a good thing, that anyone, any of the researchers who are planning on publishing, they send the manuscript, right, to the head of his research group. Again, I mentioned that seldom now we have in science people publishing on their own. Typically, they're teams or groups. Some groups are small, some groups are large, some are very large, depending on the magnitude of the project. But there will be a head or a lead on the research team. And so Robert has sent his manuscript to that head or lead person. And the head of the group says that the paper is fine, but that the supervisor of the research, as supervisor of research, he needs to be included as an author of the paper. This is the head of the research group, right? The lead fellow who is basically managing this team. His name now needs to be included in the research, even though he didn't really do anything on the research itself. Robert knows that his supervisor did not make any direct intellectual contribution to the paper. specifically this computer simulation model. All right, that was seemingly all or most of Robert's work. So, how to handle this? Should Robert just include this person who is his boss, actually? Or not? Should Robert just send the paper to physical review, ignore the request of his boss? Okay, let's look at some questions here. How should Robert respond to his supervisor's demand to be an honorary author? Okay, again, kind of open questions here. There are no, maybe no exact direct answers, but, or it could be several options, right? Anyone want to take a shot at it?
Galilea.
Yes, Galila.
So, I feel like he should definitely take it to his PI and talk about the situation,
Mm-hmm.
like how they divided the work and how like he didn't work on his part and how the work was divided. Like
I see.
definitely bring it up to him, and then bring it up to the person who's on top of the student.
Mm-hmm. Okay, I want to mention something because you bring up a good point. The PI, the notice now this is an engineering company, so it's not necessarily an academic setting. And there are kind of three possibilities in research, broadly speaking. Either research within an academic institution, which is typically going to be a university, or in industry, in the business world, right? In a company or something like that. It could even be a pharmaceutical company, or it can be an engineering company. But it's what we call generally industry, all right? That at the end of the day, in industry, they're involved in producing some product or service that that is sold to the public or to particular people. Then the third group will be government agencies that typically are funded more directly by the government, federal government, or it could be state also, or even county and local government. So these three general categories. The PI, the principal investigator, generally applies more to the academic setting, and there may be more recourse in an academic setting in the sense that there may be other professors who are doing similar research, or at least in the same department. But in industry, right, in a company, it may be more of a tight ship. In other words, because in a company, they're looking always at the bottom line of the money and how much is costing, this research is costing, and the salaries for these experts, right, all these doctors. Then it could be that in industry, these people have a little less recourse than they would have in academic setting. And for the sake of completion, in government agency may actually be the other way around. And maybe government agencies may be super regulated because they are being run with the people's money, essentially with taxes. Then they're very accountable to the scrutiny of the general public. And therefore, in government agency, there may be manuals and manuals of protocols, and all this would have been established, and there would have been no surprises. You know, that it's already written up in the policy that if any research gets published in this particular area, well, the big wigs in that area, the big bosses are going to get mentioned in the paper automatically. All right. So government agencies tend to have a lot of protocols and procedures written up over time. But here in industry, it's a little different. And the direct supervisor of Robert may be the head of the research group. So he either goes above the head to some other office of the company, of the engineering company, or to try to go laterally to one of the peers, someone else in the research group. That's another possibility. Someone who has been there for a longer period of time, all right? You notice Robert has been there for 3 years, relatively short period, 3 years. And so he could go to another member of the team, of the group, again, confidentially, and just ask, hey, is this a standard policy here? Is this an unwritten policy that whenever any one of you publishes something, the head automatically gets included or not, okay? So he may ask around confidentially. Hopefully he'll feel more comfortable with at least some member of the team that he can talk these out. But it's a delicate thing. In general, I can tell you that journals, scientific journals, they frown upon these honorary authors or gift authors, okay? It's like an honorary degree. You may have heard people earning an honorary doctorate. For example, I think that, I've heard President Obama has given some commencement speeches at past graduations at Miami-Dade, MDC. He gave one of the commencement speeches for graduation. And at that ceremony, he was awarded an honorary doctorate. But it could be that President Obama has never taken a single course at MDC in his life. In fact, MDC doesn't grant doctorates, full rigor, academic doctorates. They typically go to the AA, and in some fields, they go up to the bachelor's degree, but not even master's. So these honorary doctorates are symbolic, okay? It's just a recognition of the person, but they don't have academic standing, okay? So similar with an honorary author, scientific journals, they don't like this because it inflates the number of authors. It may give the perception of false credit to this person who really did not contribute to the research, okay? And so journals don't like that in general, okay? So again, it's something to be clarified. Hindsight is 20/20. That's why we're trying to cover it ahead of time. If some of you go into industry at some point, you may ask, what is the standard policy on that? Is it expected to list the supervisor automatically, even though she or he did not have any direct contribution to the project? Okay. Okay, what ways may be possible to appeal the decision within the company? Okay, well, again, what do we know about companies and industry different from academia, right? Different from a university or college. But typically, all of these places have an office that is known as human resources, when one can bring grievances, or they can appeal that decision. And the institution has to look at it. If there is a formal appeal requested, all right, the institution has to look at it and come up to a decision. And they have to try to look at it independently, not side automatically on the side of the supervisor or on the side of the recent arrival, as it were. So any other ideas on what could be possible appeal decisions within the company? Well, typically a company has again, some kind of a hierarchy established, right? A structure of supervisors and supervisors and supervisors. So Robert could try to approach the supervisor of the supervisor or the general manager who is managing actually all of the research that is being done at that engineering company. In other words, the boss of the supervisor. And hopefully that person is an approachable person, a person of wisdom, a person that one could approach confidentially and mention what's going on. And that person should know what is the standing policy of standing practice of the company with regards to this honorary authors. Okay, what ways might be possible to appeal the decision? Oh, I'm sorry, that's the one we were talking about, yeah. What other resources exist that Robert can use in dealing with this issue? Other resources may be outside the company, no? But certainly this is not the only engineering company that exists. Maybe in that particular town doesn't tell us who Robert is, but if it's a city, there will be other engineering companies, right? So what could he do? He could inquire, right? He could inquire if there are other, in other companies, if this is a standard practice. Also, I think I'm going to include in this PowerPoint one slide with some resources, because there's also an Academy of Engineering that may have some answers to this. It's the National Academy of Engineering. They may have some standards or guidelines with regards to honorary authors, okay? So he has access, and these academies are like the National Academy of Sciences, for example, the one that I cited for the book, for this booklet over here, NAS, all right, here, see, National Academy of Engineering, NAE. They have websites. They have websites that can be explored, and typically in those websites, there will be a section for ethics. There'll be another section for research, another section for publications. So he could look at some national standards and see if this is indeed a practice that is done at the national level. And it will have resources there also who he may contact to give him ideas on how to resolve this issue. Okay, but certainly there are resources, and particularly today with the internet, it's just amazing. He could even call some engineering journals. He could call the publisher of the journal and ask that person, or send an email to the publisher of the engineering journals and ask, is this a common practice? Any suggestions on how to handle this honorary authorship? He doesn't have to give names of company or the name of the individual, but he can ask the question in broad terms. And I'm sure he will get some feedback, because the journals are very interested in publishing properly. Okay. Anything else? So let's see. Okay, so we've covered a little bit on lab safety at the beginning, mostly on the integrity of maintaining your hours accurately, all right, on a weekly basis. And then about publishing, authors who should be listed, and how that goes. And also, what is the proper amount of data to publish that is significant, that is substantial. But a lot of open questions here. It's very important to maintain a dialogue of trust and openness, because at the end of the day, it's all about advancing the research, advancing the knowledge in particular fields. And that's also why you see today there's so many specialties, okay? So many specialties at the doctoral level that people sometimes become super specialized. You see it, for example, in medicine. You have general GPs, right? General practitioners or family doctors, but then you have the specialists. And if you ask a question that is a little specific to your general doctor, to your GP, she or he will say, well, go see such and such a specialist for the hand, for the eye, for the liver, whatever is bothering you or you have a question about, go see a specialist. Okay, today a lot of specializations, thousands and thousands, and all these are doctorate level studies. Okay, folks, well, thank you very much for participating. Any parting comments, questions, anything at all? Anything about the program? No, people good? I see all the mics are muted. Tiago?
No, I'm good.
Oh, okay.
Just
All
wanted
right.
to thank you.
Okay, you're welcome. Thank you, my pleasure. So I'll be downloading this again and a little while I'll post it, send it to Dr. Tapanes actually as a YouTube, including the PowerPoint, and then she'll put it there on the Google Drive that we have, the Google group. You all are able to get into that Google group? Yes?
Yes.
Yes.
Everybody
Yes.
okay? Good, super. Thank you very much. Okay, we'll be in touch. Thanks for listening. All the best.
Thank you, Dr. Chuff.
Thank you, Dr. Cioffi.
My pleasure. God bless. Bye-bye.
God bless. Bye.
God bless.